students, we shall proceed the next topic of discussion, multi-phase weaving. So course outcomes of these sessions are: students will be able to write the principle of multi-phase weaving. Students will be able to classify multi-phase weaving, describe mechanisms of multi-phase weavings, and explain the features of multi-phase weaving. Multi-phase weaving, continuous wave insertion occurs in multi-phase weaving. So whatever we have discussed till date, that is the single phase weaving. Okay, the shuttle weaving, the projectile, rapier, air jet, all those are single phase weaving, because the primary mechanisms such as shading, picking and beat up, they are not actually occurring simultaneously. Okay, they are occurring subsequently, one by one. At first the shade will be formed, then picking will be done, then the beat up will be performed. But in case of multi-phase weaving, so all these phases of operation will be occur simultaneously during the fabric formation. So it is require an ever-changing warp shade. So warp shades will change always. That means that the lowering and uppering of the warp shade is a continuous process. The shade will form always, and shade interchange will be done always, because the peaking is here continuous. Okay, the peaking cycle or the peaking is occurred throughout the loom cycle, throughout 360-degree angular cycle of the loom operation. So which is sometimes called wave shading. So this type of shading is called also wave shading, because the shades which are formed simultaneously, and there will be the formation of the shade, continuous shade formation and shade changing, that will appear like a wave formation. That's why this type of technology is called wave shading. There are usually 4 but occasionally 6 sets of sectional harnesses for each shuttle. Each shuttle requires 4 to 6 harnesses, and each set requires a cam unit to drive the harness. So each and every sets of sectional sets harnesses are required uh, cam for their operation. In circular loom, basically the multi-phase looms are two types, in flat and circular form. In circular form, which is more popular, in circular loom, each cam unit is mounted on its own short shaft. There is a short shaft, and on the short shaft there will be a cam, and each cam will be operated from the short shaft, and the cam will actually attach to the all sectional harnesses. Each shaft must connected to its adjacent shaft by bevel gears, and 4 sets of harnesses is required for 2x2 twill. For the formation of 2x2 twill, 4 harnesses are required. So 4 to 6 harnesses are required. So that's why maximum accommodated harnesses are 6. That's why not much many design can be possible in this type of multi-phase weaving. Generally, multi-phase weaving is popular for plain weave, simple twill weave, or simple satin weave. Multi-phase looms are of two types: circular multi-phase loom and flat multi-phase loom. Already I have mentioned circular looms, where the circular fabric will be prepared. Okay, that means the fabric will be like hose pipe in circular form. In the flat form, the flat multi-phase loom will produce the fabric in flat form or open width form, like the normal single phase weaving form, as we have already studied. In the circular loom, the 2 beams are used to supply the warp. There are 2 beams. Each processes the round, the back rest, and is then spread into circular form by a series of closed reeds. The warp shade is formed from this point. Where the series of closed reeds are there the shade formation actually occurs. Flat multi-phase looms. These looms are also unsuitable for the weaving of continuous filament yarn. Okay, these looms are not suitable for the continuous filament yarn. They are suitable for the staple yarn, and they have added to a problem of stopping the loom in the event of wave break. When there will be any wave breakage, then it is very difficult to detect and rectify them in case of flat multi-phase loom, but where it will be easy in case of circular multi-phase loom. That's why circular multi-phase looms are more popular than that of the flat multi-phase looms. mechanism, wave insertion mechanism of the circular multiphase loom. Two beams are used to supply the work, already I have mentioned, which passes around the backrest and is then spread into circular form by a series of closed threads. The warp shell is formed at this point. The series of electromagnetic blocks is rotated on the motor-driven main center shaft. The electromagnets is prevented by the intervening warp shafts, which is tensioned and thus supports the shuttle. So basically, there is electromagnetic blocks which operate to produce the formation of the shade, and the electromagnets also support the shuttle to move across the shade. The shuttle is also supported by the fixed reed that holds the warp ends at the desired spacing. It is very difficult. It is really very difficult to understand the mechanism by going through the text. Actually, the operation can be much clear when you will see the multiphase loom on your own eye. But still, whatever you can understand by going through the text and by seeing some photographs, you have to understand. The beat up mechanism. The beat up is achieved by the spike wheel mounted on an antenna trailing behind the shuttle. So beat up is actually done by some spike. The spike wheel is mounted on an antenna of the shuttle. Okay, here no such type of reed is there. The spike pick up the trailing wave and finally press it into the cloth field. So the spike is actually helps the trailing wave which is inserted by the shuttle and to reach the wave at the position of the cloth field. This is the beta. The work of the temple is done by the fixed ring. Here the temples are not there. There are some fixed rings are there which will maintain the cloth wheel, that is the circumference of the fabric in case of circular fabric, which prevents early contraction of the cloth. The ring is actually maintain the diameter of the cloth and or maintain the circumference of the cloth, and which will prevent the contraction of the cloth at the formation of the shade. The take-up motion is mounted in a high position, and the loom thus require a lofty room or space on two floors, one above the other. So rooms are basically very tall rooms, because the take-up mechanism which is situated at the high position. Okay, and that's why the two floor rooms are required uh, the the circular multiphase loom. So this is the schematic diagram of the circular loom. Here you can see this is the cloth roller where the take-up mechanism is at the top. Now at the bottom, from the bottom we shall start. Here two cloth rolls are shown here. Two warp beams are shown here, and the warp sheets are actually followed in this way, and at this position there will be the closed ribs and sectional harnesses. Here the shed formation will open. Shed formation will occur due to the action of the electromagnetic blocks. The shuttle will insert the wave thread across the series of form the shade, and then there will be the cloth field. The cloth field will be maintained by the ring. Okay, then there will be the gradual take up mechanism. Okay, take up motion which will be situated at the top of the floor. Okay, take up mechanism, and there will be the cloth roller. So this is the total material passage of the warp to the circular loom. So here the actual picture is shown. So here you can see this is the cross section of the circular loom, though it is very difficult to understand, but still the warp shades, how the warp shades are coming at this position, and how the shade formation is done, that is shown here. You can clearly see there are two shuttle here which are actually there for continuous wave insertion. So more than two shuttles can be used depending upon the circumference or the diameter of the fabric, and all those shuttle will rotate and they will continuously insert the wave yarn, and as soon as the The wave will be inserted inside the shade that will be beaten up by the antenna. Electromagnetic shuttle drive. An arrangement showing 8 shuttles equally spaced around the loom is shown in figure 2. The last figure which I have shown you, there maximum 8 shuttles can be accommodated. The appropriate position of 32 pairs of harnesses are included. So each 4 harnesses are required for formation of one shade. That's why 32 pairs of harnesses are required. The continuous lines represent the harness that control one set of alternate ends. So here, this is the cross diagram. They are the electromagnetic blocks, and these dot points are the sectional harnesses which are controlling the even ends, and these continuous lines are the sectional harnesses which are controlling the odd ends. The continuous lines represent the harnesses that control the one set of alternative ends, odd end, and the dotted line shows the position of the other or even ends. The electromagnetic attracts the metal shuttles, which thus follow the magnets in the circular path. So due to the magnetic attraction, the shuttle will move for the peaking. The attraction of the shuttle into the physical contact with the electromagnetic is prevented by the intervening warp threads. The warp threads are there in between the electromagnetic blocks and the shuttle, and the warp threads are preventing the physical contact of the shuttle with the electromagnet, which is tension and thus supports the shuttle. So in this way, the warp sheets actually support the shuttle to move for the peak insertion. So this is the diagram where electromagnetic blocks are shown here. So due to the attraction by the electromagnetic block, the shuttle will move, and continuously the peaking will be done across the circumference of the fabric. Rack and pinion shuttle drive. Now, shuttle is driven by rack and pinion also. The harness is operated vertically and in front of the reed. A series of rotating pinions is situated around the loom. These pinions engage with the rack on the underside of the shuttle, which is thus traversed around the loom. The teeth of the pinion are so shaped that the ends of the bottom warp sheets easily rest in the clearance area between the teeth and the pegs in the shuttle rack. So here the shuttles are driven by the rack and pinion mechanism, where the racks are actually at the base of the shuttle, and the pinion is a small gear which is having a number of teeth which will rotate. When the pinion will rotate, then it will move the shuttle, okay, for the picking. So this type of rack and pinion mechanism is also available for the movement of the shuttle in the circular weaving machines. Beat-up mechanism. Beat-up is achieved by spiked wheel mounted on an antenna trailing behind the shuttle. Already I mentioned at the end of the shuttle, at the trailing end of the shuttle, there will be one spiked wheel. That spiked wheel is actually push the inserted wave thread at the cloth fail. The spike penetrates the warp sheets as shown in figure 4. So here I shall show you. If this is the cloth fail, then the spike will push the inserted wave in the cloth fail. Okay, the peak pushed into the cloth fail by the spike, rotating spike wheel. So this is the rotating spike wheel. The spike wheel will continuously rotate and will catch the warp thread and push it at the cloth fail position. This causes the wheel that is mounted on the antenna arm to turn so that the spike pick up the trailing wave and finally place it into the cloth fail. Now, features of multiphase circular loom. So heavy reciprocating parts and precision system shuttle. So there are many reciprocating parts are available in this loom, and the system is very precise. Medium to coarse fabrics are produced. Lightweight fabrics are not generally produced by the circular loom. Metallic shuttle propulsion by the magnetic block and the pinion, because when we are using the magnetic blocks and pinion, rack and pinion mechanism, always we prefer the metallic shuttles. Wave shade is produced and shade is vertical. So here the shade is not horizontal, shade is actually vertically positioned or vertically formed. Okay, heel frames are horizontal in nature here, but in the single phase loom, heel frames are vertical in nature. Here heel frames are horizontal in nature. For plain weave, 32 harnesses are used. For preparation of a plain weave, minimum 32 harnesses are required. So although they have been used for quite some time, these multiple looms have been used for quite some time. Okay, circular weaving machines, they are not not frequent textile industry. The circular weaving machines are very rare in textile industry. They are not very frequent. The main reason of this lack of flexibility in the fabric with a narrow range of options because of the less popularity of the multi-phase looms are due to its lower flexibility in the fabric width because we cannot change the fabric width much and the narrow range of option design only we can produce few plain twill and satin. Only sack and tubes are woven on circular weaving machines. Usually only plain and twill weaves are possible. In a circular weaving machine, the warp is circular and there are continuously circulating shuttles running around the periphery in a wave or ripple shape. Already I have discussed, shuttle cannot leave the shade and have a continuous motion. So in this particular type of loom, the shuttle will never come out of the shade. When the shuttle will complete the complete its traverse from one shade, it will just enter to the other shade. The mechanism will be like that. Continuously the shuttle will insert the wave. Shuttle are driven electromagnetically and each shuttle runs in its own shade. Warp is divided into two segments and forms the shade with small heel frame and wires. The beat up is performed by the needle gears. In the warp direction shade wave principle, a number of shades are opened in the warp direction at the same time for the wave insertion. So basically when we are talking about the warp direction shade wave principle, the number of shades are opened in the warp direction at the same time for the wave insertion. These shades are opened one after another in the warp direction only. However, there are several shades that are open at any given time. Okay, this is the main features of the warp direction shade wave principle. Each shade extends across the full width of the warp and moves in the warp direction. Thus, the wave turn can be inserted in a manner similar to that of the conventional weaving system. This concept is called sequential set principle or multilinear set principle. Okay, this is very important terminology in case of multi-phase weaving, sequential setting principle or multilinear set principle. Compared to the single-phase weaving machine, 3 to 4-fold productivity with simple standard fabric. We can get the 3 to 4 times high productivity with the multi-phase loom than that of the single-phase loom. The warp end pass over the rotating weaving rotor. The shades are formed consecutively its circumference by shade forming elements. Motion of the motor causes the shade forming elements to open the shade one after another. The wave turn is inserted by low pressure compressed air through the channel across the full width of the fabric. So wave turn sometimes also inserted by low pressure channel. 4 peak can be inserted simultaneously. You can insert 4 peaks simultaneously. The yarn velocity is around 20 meter per second and insertion rate about 5000 meter per minute, which is near impossible in case of single phase weaving. Beta combs are located on the weaving rotor between the rows of set forming elements perform the function of the conventional reed. So beta combs or also sometimes they are called as spikes. Okay, so they are the similar meaning in different books. The names are different. They actually perform the function of the reed. So these are the some actual photograph, okay, of the circular weaving machine, multi-phase circular weaving machine, where you can see this is the set formation element. These are the set formation element. So these elements actually making the warp shades up and down for the formation of the set. This is number one. You can see, okay, the beta combs are these are the beta combs. Okay, these elements they actually help for pushing the warp yarn at the crossfell position. Okay, and these are the wave channel through which the wave insertion will be taken place. So in this way there will be the numbers of elements 1 2 3 and there will be a series of these numbers and that will you can actually will see the surface of this drum. in this way, and how the yarns are wrapped over this drum, and they will continuously make a wave of shade, and the shuttle can be inserted continuously. The wave insertion can be done across the weaving cycle. Okay, so here the beta shade geometry is shown here in this diagram, how the shades are formed by these are the shade formation element. So how these elements are forming shades. So this is one shade, this is another shade. Okay, so how these shade elements are catching the warp yarns and forming the shades for making the positions of shuttle insertion. Okay, here you can see the position of the threads. Okay, and the bit up comb, how the bit up combs are actually performing the bit up after the whipped insertion when the drum will rotate. Okay, here four shuttles can be inserted simultaneously for the whipped insertion that you see. So here you can see if the four shuttles are used simultaneously for the whipped insertion, then the productivity will be just 4 times than that of the single phase weaving. So in circular loom, 8 shuttles may be simultaneously be employed for the weaving. Then 8 times productivity will be there. The split harnesses are used for the shading. The split harnesses I have shown in the diagram. The complete rotary motion in the line with wave knitting machine. So the rotary motion is just like the wave knitting machine. You must have learned. Okay, no, I think you will learn the knitting technology in the next semester or seventh semester. So then you can understand there is a similarity between the wave knitting technology and the circular multi-page weaving. Reed is fixed and it controls the warp spacing basically. Reed is fixed here, so reed is not there. It is called the spike. The rotating spike wheel is used for the beating up. Multi-phase, multiple warp beam are simultaneously used. You see, I have shown you the diagram where the two warp beams are used for the formation of the circular cloth. So you can use more than two beams also. So these are all for the multi-phase circular weaving machines. So in brief, I think this is sufficient for you for your preparation, and you can also follow the book of Marks and Robinson. Okay, for your study material, and as well as the book of NQ. In the book of NQ, there will be a detailed chapter is there on the multi-phase weaving. The chapter is little difficult, and but which is interesting to go through. Thank you. Happy learning.